Numbering system. In our previous class, we actually have seen what are the different base numbers that we have. So very quickly, we saw base 2, which is binary. We saw octal. We saw decimal, and also there's hexadecimal, right? And we've seen how to perform conversion between other base numbers to base 10, and also from base 10 to other base numbers. And we notice that most of the time we'll do conversion from binary to hexadecimal and vice versa. And we also have seen that hexadecimal and octal is like has a natural correspondence with binary, and it also acts like a compact representation for binary, and the reasons we have discussed before. Then after that we went into binary addition and subtraction, just for you to rekindle back your memory on how to perform the addition and subtraction. Then we went into two's complement number system. What is two's complement number system? It is a number system used within a fixed limit or fixed length number, because in digital hardware you have fixed length of number. I gave so much examples on different architectures of computers and how it corresponds with the data length. And we saw how do we represent the positive or negative numbers is by the most significant bit. If it's 0, it is positive. If it's 1, it is negative. And then what we saw now, when we have a fixed length of data, for example, that the microcontroller that we're using, or the PIC18, is an 8-bit microcontroller, which means it can only process a data of 8-bit at one time. Now, out of the 8-bit, if you have taken the most significant bit out as a sign, that means we have only 7 bits left. And we saw the formula to see what is the range of the positive and negative numbers that we can represent. So you remember the formula? 2, negative 2 by the power of n minus 1. Why n minus 1? Because one of the most significant bits we have already taken out to represent as a sign. And then we saw the range. So for different bit numbers, of course, the range may vary. Then after that, we actually saw what we saw? Negation. Under two's complement numbers operation, we saw negation. Negation is nothing but two's complement or negating a number. A positive number, when you negate, it becomes negative. A negative number, when you negate, it becomes positive. Now, what is the steps to perform negation? It is simple. It has a two-step thing. The first one is you perform one's complement. One's complement is nothing but performing a toggle. 0 mean becomes 1, 1 becomes 0. After you perform the first complement, then you just plus 1. Or you add 1, and that you get the two's complement number. And then we went into addition. I think we stopped at addition, The second example of addition is -13. So we already completed it? Or no? This, the example that we saw is this one. This 97 decimal class with -13. So in our previous class, we have actually learned how to use the weightage system to represent a negative number. So in this case, because we are using 8 bits number, so it's good for us if we can write the weightage of the numbers. 1, 2, 4, 8, 16, 32, 64, 1 to 8. These are the weightages of every binary position. So since we have 8 bits, so that's why I have written down the 8 bits weightage number. So now, even though this is given decimal, if you solve it just like this, yes?
Switch on the light.
It's not that I don't want to switch on the light. The light is not switching on. Can you come in front? No, I tried pulling this so many times. Even Aladdin would have come out from there now. Nothing's happening. Something happened. Something said disabled. I just don't know why. Can both of you shift a bit in front? This one can have 3 rows. Anyone knows these technicalities which builders mean? This is one thing which I can't figure it out. Yeah, try this. There's no more switch inside. I press all the way. I don't know what to press. Can you all just come in front there? Is it okay? I don't know, this class sometimes the light is on. Anyone knows how to solve this? Pause the technician. Technician won't be here. No. This is quite funny because when I press medium, the front comes like. Anyway, now we are in the right. You all in the dark. So I think it fixed one problem and created another. Anyway, at least the screen is bright. Can you all see? Yes. You can actually put some LED light here. Anyway, now. Person in the back, now where are you? Over here. My life got brighter, you got never mind, at least you can record now, right? Okay, coming back to the point, how do we actually write this 97 decimal into binary? We see which weightage is closest to 97? 64. What's the balance, remainder? How? 33, right? How do you represent 33? 32 and then 1. So you get 97. Then you need to plus with negative 13. Now what is the step for us to get in binary? First of all, we minus the decimal number by 1, which you get 12. How do you represent 12 here? 8 and 4. But then now you represent with 1 or 0? You represent with 0. 8 and 4 gives you 12. So the remaining is 1. Is this okay? Any question, any doubt on this? Can everyone at the back hear my voice? At the back, at the back. Hello. Those at the back, can you hear me? Any question on this? Just can tell something like no. Deepan, what's the problem?
Last week I went early, so I didn't know how to get the
first one.
This one? First one. Okay, usually when we want to convert a decimal number, we saw this in the conversion part, right? In the earlier lesson, that when we want to convert the decimal number to binary, we will perform the long division. We'll actually divide with the base number to get the binary value. But then there's a shortcut of doing, of course shorter than the shortcut is actually a calculator. But then when it comes to negative number, your calculator cannot do that. So what I prefer to do is, since this is an 8-bit 2's complement number, might as well write down the weightages for all the 8-bit values. This is okay? Now the first step is, this is a positive number. So for a positive number, we just solve it like a normal binary. So how do you do this is, which one of this weightage is actually closest to 97 but smaller than 97? It is 64. So 97 minus 64, you get remaining 33. How can you represent 33? 32 plus 1. Done? You managed to get 97, right? Until you get 0. So the remaining, you fill it up with 0. Is that okay? Now for a negative number, you have to do in reverse. Actually, in our the first class, we did the conversion from binary to decimal, right? So what did I mention about the negative 2's complement binary? If it's negative, you take the weightage of the zeros, you plus 1. Why are you looking at me as if I have never mentioned that before? Did I mention or did I not mention? I should have mentioned that, otherwise we wouldn't have come until this point. But I know it will do a lot of damage to your brain, and my brain as well. So just to recap, when you, myself just write it down here. Let's say if you have a 4-bit number and this is a 2's complement number. So what you do, you look at the most significant bit. Why? Because you want to determine whether it is positive or negative. If it's positive, then you just add the weightage of the 1, like how you do with normal binary number. So it's easy. Positive is just like binary. But if it's negative, then you need to look at the weightage of 0. Of course, there's another way that we did was, in order for you to know what is the actual value, then you perform negation or you perform 2's complement, you'll get back the positive value and you know that is the negative of this positive value. But another shortcut is what you can do, you can write the weightage of these numbers. But now what you do is you take the weightage of the 0. So what is the weightage of the 0? 4 plus 1 and you must always plus 1. So this one is equivalent to negative 6. Now if you don't believe, you perform 2's complement. When you perform 2's complement, you perform the first complement and then plus 1, right? Do you get 6? So, do you understand the concept? So likewise here, we are doing reverse now. From decimal we are going to binary. Earlier it is from binary to decimal. So from binary to decimal, if you are taking the weightage of 0 is plus 1, now from decimal to binary you should do the reverse. So the decimal value you should minus 1 first. So in this case, this is negative 13. Negative 13 minus 1 is 12. Of course, don't take negative 13 minus 1, then you get negative 14. Take the value 13 minus 1. So 12. How can you represent 12? 8 and 4. But now use 0 instead of 1. And when you fulfill that value, 12, the remaining you fill it with 1. And you know that this is negative. If you don't believe, you take this one, perform 2's complement, you'll get back negative 13. Any questions? Can I move on? So help me with this addition. This you get 2. You get 2, 1, 0, 1. This you get 2. You get 3. This you get 2. We have carry. Always remember, if you are adding 8-bit or whatever bit length, the answer should be the same length. Whatever extra that you get, that is carry. So don't take that into consideration. Is there any question so far? Can I erase this part? Is that okay? Can we move to the next one? So now we're going to see 2's complement subtraction. 15 minus 8. Now we know that both are actually positive numbers, right, in one sense. So this will be quite easy. Again, you write back the weightage. So 15. How do you get 15? This is quite easy, lah. This one you need to minus, now we minus. Then if you are minusing it, positive 8. 8 is? Is this okay? Now help me to perform the subtraction. 1 minus 0. 1, 1, 1. This is 0, 0, 0, 0. It's easy, lah. It's too easy. So the only thing that you need to be aware of using this technique is just to convert these decimal values into its equivalent signed number. After that, remember earlier we did binary addition and subtraction. The principle are the same. If here not enough, you have to borrow and things like that. Any questions so far? Can I erase this part? This one? If the replacement class is COIT, is it okay? moving on with the topic, we're going to see overflow. So this overflow, before that, should have asked you. What is overflow? Based on what you learn from digital logic. Don't worry about writing. Participate in the class discussion. What is overflow? Extra money. You know that never happens, right? What is overflow? Don't take the word literally, because if you're thinking overflow means pour juice and overflow. That's not overflow. So just to save time, overflow can occur only in signed number operations. Signed number operation means in two's complement number system. So what is overflow? Overflow is actually can happen in two conditions. One is when you perform addition, or one is when you perform subtraction. So these two, addition and subtraction, only valid. I mean, there's also addition and subtraction in binary, but a normal binary addition and subtraction doesn't denote overflow. But in signed addition and subtraction, yes, the overflow comes. So the question comes is, what is overflow? Overflow actually occurs when the sign of the result is actually wrong. So for example, if a positive number plus with positive number is supposed to get positive, right? But if you get negative, that is overflow. Overflow means getting the wrong sign, not value. Overflow has nothing to do with value, it's the sign. The sign convention which matters. So let's take another example. Negative plus negative.
Plus, negative.
Negative plus negative is supposed to get negative. But if you're getting positive, that is overflow. If you have negative, I think, plus negative, sorry, I already said that right. Let's say negative minus positive. Negative minus positive. Still negative lah. Still get negative. Negative. Right, what? Why am I going to get right? If you have, let me see. Yeah, positive and negative, then that depends which number is actually bigger. If the one is bigger, then you'll get positive answer. If the negative number is bigger, you get negative answer. So like that, you understand the logic. The answer sign must be correct based on the two numbers. If you're getting the sign wrong, that is actually overflow. There's nothing to do with the answer. If the answer is wrong or whatever, that's not overflow. Overflow is just a sign convention only. That's clear? So there's tips for you to determine the overflow, a hint. So when you perform addition, overflow may occur. May occur when adding a like or same sign. What is a like or same sign? That means you're adding positive with positive, negative with negative. If you're adding same sign, may get overflow, may. But if you are adding unlike sign, that means negative plus with positive or positive plus with negative, it is impossible to get overflow. Of course, I didn't write here, but I want you to write if you're interested. It is impossible to get overflow. Likewise, when you perform subtraction, overflow may occur when subtracting an unlike sign. That means negative minus positive or positive minus negative, unlike sign, may get overflow. But if you are subtracting same sign, that means positive minus positive or negative minus negative, it is impossible to get overflow. So you can use this as a reference. Now when I say reference, not to bring as a examination time. It's for you to actually learn. Is it okay? Now let's see an example. Does overflow occur for the following 8-bit operation? So let's take the first example. This is a subtraction. Now let us analyze this. This is a subtraction, right? And this is positive negative. This is positive negative. So that means same sign. So if same sign performs subtraction, can you get overflow? No. It is impossible to get overflow. So you are telling mission impossible or is it correct or not? Now let us try to solve it, then we will know. 1 minus 1, obviously it's here. 0, 0, 0, 1, 1, 1, 1, 0. You still get positive? So that means positive minus positive. Actually this one actually also depends, right? This is positive minus positive. If this number is bigger, the answer become positive. If this one become bigger, it will be negative. So how do you know which number is bigger? Just by visual inspection. Yes, simple, small ones. Small ones. So it's simple, just by visual inspection. Anyway, Prajin rule says that it's impossible as a cannot get, I'm telling you. So in test, especially in test 1, if you see in Moodle there's a lot of resources. For last semester's one I'll upload it. There's one particular time where I have not uploaded anything because I was on study leave for more than a year. So that material I don't have access, so I didn't upload. So for last semester's one, I'll upload all the materials, the past tests. So if you see in test 1, there's a lot of, there will be a question asking on the overflow, how to perform 2's complement, things like that, because there is one of your course outcomes to be able to perform numerical operations. Okay, let's see the second example. Can I erase the other side? So this one there is no overflow. Let's see the second example. This is addition. This is positive and this is positive. So performing addition of same sign. So could we get overflow or no overflow? Yes. May get overflow. So we have to check. So let's try to solve this. This is 1, this is 0, this is 1, 0, 0, this is 2, this is 3. So you see that you get negative. Positive plus positive is supposed to get positive. What are you getting? Negative. So this is overflow. So always whenever in tests you read the questions properly and try to answer according to the requirement of the question. If the question says solve the 8-bit addition operation and determine whether it overflow or not. So the first step is you need to solve it and then you need to write there is overflow or there is no overflow. So some students they solve. Then they tell the paper, yes, there is overflow. But they never write, so you won't get the marks. The marks also I'll tell, yes, you got 1 mark. It happens all the time. So that's why I always tell students to underline or highlight the requirement question so that you don't miss it. Shall we see the next one? This is subtraction. Subtraction of unlike sign. So can we get overflow or no overflow? Maybe. So we have to try. So this is 1, 0, 0, 0, 0. This one you don't have anything, so you have to borrow from this guy. 2, when you borrow from this guy, becomes 1. Then this guy becomes 1, this is 0, this is 0. So, is it right or wrong? This is the negative. Negative minus positive is supposed to get what? Supposed to get negative. Negative minus positive is supposed to get Negative. What are you getting? Positive. So got overflow or no overflow? Yes, there is overflow. Can I erase the part? How about this one? Can I erase this one? Question up to this point. We're just recapping on the numbering system. So we are going to go to the last subtopic of numbering system. Then we'll enter into the chapter 1. But before that, we'll do some tutorial questions. This Thursday, there won't be any tutorial class. This Thursday, there won't be any tutorial class because I'll be outstation. Okay, so we'll try to do that tomorrow. Is it okay if we go to the last one? So this is the last part that we want to recollect, which is on BCD, binary coded decimal. From the name itself, you can know what it means. So decimal means decimal value is from 0 to 9. And what we want to do is, BCD is actually each decimal digit is represented by 4 bits binary digit. That means in decimal you have 0 until 9. Every decimal value is actually represented in binary. That's why they call it binary coded decimal. So it means 0 means it will be 0, 0, 0. 1 means it will be 0, 0, 1. 2 means it will be 0, 0, 1, 0. 3 means it will be 0, 0, 1, 1. Until 9 will be 1, 0, 0, 1. Is it okay? Now this one, this binary coded decimal, we will be using this. This comes very helpful or handy when we want to display values on 7-segment display. Do you know what is a 7-segment display? It has 7 segments, that's why they call it 7 segment. You can display numbers, right? So later when we come to chapter 7, we'll actually see that this BCD comes in handy to display the value. Till that time, just keep in mind, back of the head, there's something as BCD. So is there any question? Did you all download tutorial 1 yet? Some yes, some no. Anyway, I should tell you to download. But I will try to do some of the tutorial questions straight away. So before that, we'll take a short break by me nagging you. So nagging means there's a career fair coming, right?
Yeah.
So how many of you going career fair? My piece of advice is all of you should go for the career fair. So why? We are now in second year. The reason is since next semester you might be going for industrial training internship. So what you should do is, you should go and visit all those potential employees, your potential employees. So you go and visit the company. What you do is you can ask them whether do the company actually offer internship. So if they offer internship, you can get the details. Can I actually have your HR email so you can send the details? Because you are visiting the company, you can ask them what type of company is this, or what do you do. So if you find, oh, this is quite interesting, I think I would like to try to work in this company. Of course, some company may say, no, we don't take interns, we are just seriously looking for graduates. Never mind. So you go every company you go and they say, your company is a very well-known company, the best in Southeast Asia. I would like to, it's a privilege for me to actually work as an intern in a company. Do you offer interns? Then you go another company, sir, your company is the best company. Southeast Asia. Big privilege for me. Then after that you go to the company, sir, your company is the best company, sir. It doesn't matter like you have the same pickup line, but make sure don't screw up lah. That means if two different companies beside each other, you don't go and tell sir, sir, your company is the best. So just do it in a nice way. So you have to put in effort. Because there's a lot of companies coming here instead of you going out. Because some students, they do not know what kind of internship company that they're going to get. Some of them, I don't care, I just go. Some of them, just my father's company is there. So like, there's one student, he was doing intern in his father's company. Every day he'll come with the Bentley. He said, I want a Bentley, right? Nah, it's okay. Then some, but of course he does work lah, I assume. He does some work and he showed me some proof of work. So it'll be good that if you can plan for your intern. And if you get a good internship, that will be an added value for your CV. After you have completed your internship, you come back next year. Again, you should go for career fair. The reason is, that means next year when there's a career fair, again you go. But this time you go, you ask for them what kind of vacancy that are you offering. Then they'll tell, no, we are actually open for process engineer or R&D engineer. Then you ask them. So first you ask them, this is after, I don't now go and ask them, what vacancy you have now? What year they ask you, second year, they'll shoot you, go. Take note that some of them may be very friendly, some of them may not be friendly, but don't take it to offense. After all this finished, then you gather with your friend, make fun of them. Okay. So don't worry about that. Some of them may be very friendly, some of them may not be friendly. But don't take it offensive. They are looking for people. Don't worry, just you are looking for some opportunity. So next year, after your internship, when you come back, again there's a career fair. You go, you ask for them. The first question is, what is the post that you're offering? Second question you ask, what is the job description? If you tell process engineer, what do you do? Then you tell, no, you have to work on network system, then you have to do this, the layer of the wireless communication, and make sure the packet reaches or whatever. You do router settings, and you program the router and whatever. So then, this sounds interesting. Then the third question you ask, what are the subjects that I need to take to meet this requirement? So at that time, you can actually print out your course outline. You have the elective side. You can ask them, which elective should I take? They say, okay, you should take datacom. If you want this one, you should take this. So when you come to the final year, you will know what elective to take. Because I've seen, I feel pitiful. Sometimes students come to me and finally say, so what should I take? I say, what do you like? I don't know. Tell me what you really like. I like the girl beside me, but I mean not that. What you want, like. Many of them don't know. They feel very lost. So that's why I always like to advise earlier. But if you want to take or don't take, that's up to you. So that time, at least when you see, you can actually project, okay, which company that you want to work. Then you will know what subject you can take to help you to get into the company. So this way, you have some roadmap for you. Is it okay? So let's try to do some tutorial question to enhance our understanding of the numbering system. It's okay if you don't have tutorial question. Okay, don't worry about writing the question. I'm just going to read out the question. I'm not going to write back the question. But then Okay, great. I do have a question. So if you see in your tutorial 1, there will be 5 questions in tutorial 1, out of which the question number 1 and question number 2 we shall ignore. The reason why is the first question is for you to perform conversions. Now, those question was during the era when the calculators were not allowed. Now you have calculators, so definitely there's a piece of cake. The second question is a floating binary digit. We are not covering it, part of our syllabus, so we are removing that. So we're going to target question number 3, 4 and 5. So what we have in question 3, I can project it, but when I project it, half of the board will be gone. Not half, the full board will be gone. So that's why. Let me try to recall it back. What's question number?
Project there. Project there.
But the projected sheet, oh, not HP. So I'm going to go to question number 3A. Okay, the question, okay, I'll just write down this. So this question number 3 says that given this 2's complement number, perform the addition and also subtraction and indicate whether if there's overflow. That's the question. You don't have to write, you can actually, or some of you can refer also. Is that what the question says? Add and subtract the following 2's complement numbers, indicating if an overflow occurs. So that means the first one, it gives these 2 numbers. So that means you have to perform addition and also you have to perform subtraction. So it's already mentioned that this looks like a normal binary, right? But since now they mentioned that this is 2's complement number, so that means these are signed numbers. So there is 2 elements to the question. The first element is it asks us to perform addition and also subtraction. The second element is it asks us to actually indicate whether there's overflow or not. So what we will do, we'll do the first segment first. That means we'll perform the addition of these 2 numbers and also the subtraction of these 2 numbers. Is it clear? Yeah. I mean, no, in class. Okay. So of course, the knowledge earlier which you learned how to perform the binary addition subtraction, it just applies the same here. Nothing different. So when you perform addition, this is 1, this is 2, this is 2, this is 3. So you get carry. So remember, in 2's complement number system, if you're adding 4 bits number, the answer should also be 4 bit. If it's 6 bit, then it will be 6 bit. If it's 8, the answer should be 8. Anything excessive out of that is known as carry. And we'll consider this later on in chapter 2 onwards. Let's try to perform the subtraction. This is 1, 0, 1, 0. Simple. The first element of adding and subtracting is not a big deal. Can be easily done. The same knowledge as binary addition and also subtraction. The next question now we want to answer is there overflow or no overflow? Let's see the first one. Do we have overflow?
Yes.
Why do we have overflow? Based on the hint that we have. When we add same sign, can we get overflow? May get overflow. So what is this number? Negative. What is this number?
Negative.
Negative plus negative is supposed to get?
Negative.
Negative. Right? Why did you calculate for that? Oh, jauh macam. This is a negative number. Negative number plus in negative, you will get negative. Don't worry, if you try to solve 2's complement calculator, you get wrong. But your calculator is operating in 2's complement number system. All your digital things operates on 2's complement number system. So there is overflow.
No.
There is no overflow. There's no overflow. You all understand this? Those at the back, those in the darkness, Jedi Knights. Fine? Any questions so far? Can everyone at the back hear me? Is it okay? Now if you cannot hear me, just raise your hand and just ask. Don't at the end of semester say actually your voice I never hear the whole semester. Can you repeat back? So don't do that. If you can't hear, then just raise your hand, sir, I cannot hear. Cannot see means I cannot see this color, can I change different color? So just give feedback. So this one, let us say this one. This is we performing subtraction. Under the subtraction rule, if you subtract same sign,
Not possible to get.
it is impossible to get overflow, right? So confident.
Okay.
No overflow. But somewhere inside your heart you have to doubt. So let us try to confirm this. Negative minus negative. The answer? No. Not necessarily. Right? It depends. So now you know both negative. These both are negative. So what is this value in decimal?